If you ever worked in automotive or even interested in automotive development, you probably heard terms like design freeze, FOT, CPOT, or SOP. Most people hear these words, nod their head, and just move on. But in this video, I will explain the important milestones for parts in a very simple language, no textbook definitions, no unnecessary jargons. By the end of this video, you'll clearly understand how an automotive part moves from CAD to production. First of all, why parts milestone exists in first place? As you know, a car is made of thousands of parts. Each part is designed by engineers, manufactured by suppliers, validated by quality teams, and finally assembled on a production line. Even if one critical part is late or unstable, the entire vehicle launch can be delayed. That's why automotive companies use very clear milestones. These milestones make sure everyone is aligned and the problems are caught early. At a very high level, every automotive parts follows this journey. First the design, then the tooling, then the validation, and then the production. Now let's break this down into key milestones inside the journey, only one that actually matters. First milestone is design freeze. Design freeze means the part geometry is frozen. After this point, major geometry changes are not allowed. Tooling decisions are based out on this design freeze data. This is critical because toolings are expensive and time consuming. If the design is unstable here, the problems show up later and causes delays, cost overruns, and firefightings. The next milestone, a tooling release. Tooling release is when the final CAD data is officially released to supplier. This means a tooling manufacturing is started, okay, and then lead times begins and the costs are committed. After tool release, even a small design change can mean a tool rework or a schedule delays or even extra cost. This is a point where no easy changes are made. Now comes one of the most important milestone, that is FOT. FOT stands for first of tool. This is the first part manufactured from production intent tooling. This is where theory meets reality. So what is checked at FOT? At FOT, a team checks like dimensions, material behavior, surface qualities, warpages, cracks or sink marks. So in short, overall manufacturability. So FOT answers one simple question. Can this part actually be manufactured the way we have designed it? After FOT, very few parts are perfect. This phase is called as tool tuning or tool correction. So based on the FOT feedbacks, the tool inserts can be adjusted, the cooling lines are optimized, or the gating or the draft angles may be corrected. The most parts needs one or two tooling loops. This is normal and is necessary to get the good quality parts. Once the part meets all the key requirements, it is approved. Different companies call it differently. Some call it as part approval, some call it as tool OK or CPOT, which is confirmed part of tool. The name doesn't matter. What matters is the intent. This milestone means the design is locked, the tool is locked, and no major changes are expected from here. After part approval comes the PPAP. PPAP stands for Production Part Approval Process. PPAP is not about just the paperwork. It proves one thing: the supplier can make this same good part again and again, and the required at the required production volume. So this milestone gives confidence for mass production. Next comes the SOP, the start of production. Even after SOP, part teams stay closely involved in NPD, that is new product development. Early production is monitored for any fit issues, quality concerns, or any line problems, and then they are corrected. Only after production stabilizes does the part truly becomes normal in production. So in summary, so if you remember only one flow, remember this. It starts with design freeze, then the tooling release, then the FOT, the tool tuning happens, then the part approval or CPOT happens, then the PPAP and the SOP. So these milestones decide whether a part launches smoothly or becomes a constant problem. So now when you hear these terms, you actually know what's happening behind the scenes. So that's it for today. In the next video, I'll explain why late design changes kill automotive programs with real industry examples. If this video has helped you, like it and subscribe and share it with someone starting their automotive journey. Yeah. Thank you and see you in the next one.